Hi everybody, welcome back to the channel. Today I'll be doing the short answer question for 3 marks from the Cbse additional practice questions released in 2023. And the question is from the lesson linear equations. Now the question is given below is a pair of linear equations 2x minus my equal to 9 and 4x minus ny equal to 9. You have to find at least one pair of the possible values of m and n if it exists for which the above pair of linear equations has, in the first case, a unique solution, the second case, an infinitely many solutions, and in the third case, no solution. And you have to show your work as well. Okay, so let's start with the first part. Equations to have unique solution, the condition is a1 by a2 should not be equal to b1 by b2. So in the first part, for unique solution, we know that a1 by a2 should not be equal to b1 by b2. Now the two given equations are 2x minus my equal to 9 and 4x minus ny equal to 9. Okay, so let's try to find out the values of a1, b1, c1, etc. from the first equation. A1 is the coefficient of the x term, which is 2. b1 is the coefficient of the y term, which is minus m. And c1 is the constant term. a2 is the coefficient of the x term in the second equation. b2 is the coefficient of y term in the second equation. And c2 is the constant term. Now for unique solution, we know that a1 by a2 should not be equal to b1 by b2. Okay, and we know that a1 by a2 is 2 by 4 in this case, which is 1 by 2. So we should find out values such that m by n should not be equal to 1 by 2. Now you just have to think of two equations. Fill in the values for m and n here in the two equations such that they will not become equal to 1 by 2. So that is 2x minus, instead of m, let me assume maybe 5y equal to 9. And instead of n, if I assume maybe 4y equal to 9. Now you can see that from the two equations that a1 by a2 is 1 by 2 but b1 by b2 is not equal to 1 by 2. So that means this will be a perfect example of two equations with unique solutions. So I have assumed the value of m is equal to 5 and n is equal to 4. Okay, now let's look at the second question where they've said you have to find values for m and n such that they will form infinitely many solutions. Now, what is the condition for infinitely many solutions? For two equations to have infinitely many solutions, we know that a1 by a2 is equal to b1 by b2 and should be equal to c1 by c2. Now, from the two given equations, we know that a1 by a2 is 2 by 4. Which is equal to 1 by 2. b1 by b2 we know is equal to m by n and c minus m by minus n, and which becomes m by n, and c1 by c2 is equal to 9 by 9, which is 1. Okay, now you can see that a1 by a2 is not equal to c1 by c2 already. a1 by a2 is 1 by 2, whereas c1 by c2 is equal to 1. So that means these equations can never form infinitely many solutions for any value of m and n. Okay, so we would mention in this case that we can conclude that the required condition can never be satisfied. Okay, so it is not possible to frame a pair of linear equations having infinitely many solutions. Okay, now let's look at the third question. Third one is you have to find the values of m and at least one pair of possible values of m and n such that the equations will have no solution. Now, what is the condition for two equations to have no solution? For no solution, we know that a1 by a2 should be equal to b1 by b2 but should not be equal to c1 by c2. And A1 by A2, like you know, is equal to 1 by 2. And B1 by B2 is equal to M by N. So we just have to assume some value for M and N such that their ratio will become equal to 1 by 2. And in this case, let me take maybe M as 4 and N as 8. Okay, so the two equations would become 2x minus 4y equal to 9 and 2x minus 8y equal to 9. Sorry, not 2x, 4x minus 8y equal to 9. Okay, so you can see that the value of A1 by A2 here is 1 by 2 and the value of B1 by B2 also becomes equal to 1 by 2, but C1 by C2 is 1. So this pair of linear equations now have no solution because the value of A1 by A2 is equal to B1 by B2 but not equal to C1 by C2. I hope the question is clear. If you have a math question that you'd like me to cover, drop it in the comments and I'll be happy to do a video just for you. Also, if you like my video, please don't forget to like, share and subscribe. Thank you.